DisplayPort. DisplayPort technology, the high-performance standard for modern computing. DisplayPort is a digital display interface developed by a consortium of PC and chip manufacturers and standardized by the Video Electronics Standards Association, also known as VESA. While HDMI was born out of the consumer electronics world of televisions and home theaters, DisplayPort was designed from the ground up to be the ultimate video interface for computers. It is the successor to legacy standards like VGA and DVI, and offers several unique technical advantages that make it the preferred choice for high-end gaming, professional graphic design, and multi-monitor office setups. For an IT technician, understanding the packet-based architecture of DisplayPort is essential for troubleshooting modern high-performance workstations. The packet-based architecture. The most fundamental difference between DisplayPort and almost any other video standard is how it moves data. Most video interfaces, including HDMI and the old analog standards, send a raster scan or a continuous stream of data. DisplayPort, however, works more like a network connection. It breaks the video and audio information into small micro-packets. This packetized approach is incredibly powerful because it allows DisplayPort to be flexible. It doesn't just send one fixed stream of video, it can carry multiple streams of data over the same physical cable. This architecture is the foundation for features like multi-stream transport and the ability to carry non-video data, such as USB signals, alongside a high-resolution image. Because it operates more like a data bus than a traditional video cable, it is much easier for engineers to increase its bandwidth through software and firmware updates. Multi-stream transport, the power of daisy chaining. One of the most popular features of DisplayPort is multi-stream transport, commonly abbreviated as MSD. This technology allows a single DisplayPort output on a computer to drive multiple independent monitors. There are two main ways a technician can implement this. First is daisy chaining. If you have monitors that support MSD, you can plug the first monitor into your computer, then plug a second monitor into the output port of the first monitor. The computer sees both monitors as separate displays, allowing you to extend your desktop across them with only one cable connected to the actual PC. Second is using an MSD hub. This is a small device that plugs into one DisplayPort on your laptop and provides 3 or 4 DisplayPort outputs for your monitors. This is a lifesaver for modern, thin and light laptops that may only have one video output but need to power a complex multi-screen workstation. It is important to note that the total resolution of all connected monitors cannot exceed the total bandwidth of the single cable coming from the computer. The evolution of DisplayPort versions. Like HDMI, the physical DisplayPort connector has remained constant, while the capabilities inside have increased significantly with each new version. DisplayPort 1.2, released in 2009, this was the version that introduced MSD and doubled the bandwidth to 17.6 gigabits per second. It was the first version capable of driving a 4K monitor at a smooth 60 Hz. Even today, version 1.2 is very common in corporate office environments and remains the baseline for professional work. DisplayPort 1.4, this version introduced a critical technology called Display Stream Compression, or DSC-DSC, is a visually lossless compression algorithm that allowed DisplayPort to push way beyond its physical limits. With DSC enabled, a version 1.4 cable can support 8K resolution at 60 Hz or 4K at an incredibly fast 240 Hz. It also added support for HDR10, providing the deep colors and bright highlights required for modern professional media production. DisplayPort 2.1, this is the cutting-edge standard, offering a massive leap in raw bandwidth up to 80 gigabits per second. This is designed for the most extreme gaming monitors and ultra-high-resolution professional displays. It is capable of driving two 16K displays at 60 Hz simultaneously. Version 2.1 also improved how DisplayPort works over USB-C cables, ensuring better stability when using a single cable docking station. Connectors and compatibility. DisplayPort features a unique connector design that sets it apart from the friction fit of HDMI. The standard DisplayPort connector, the full-size connector, features a locking latch mechanism. When you plug it in, two small metal hooks click into place, preventing the cable from being accidentally pulled out. To remove the cable, you must press down on a button on the connector to retract the hooks. Technicians should always warn users about this, as many people have accidentally damaged their expensive graphics cards by trying to yank a latched DisplayPort cable out by force. The mini DisplayPort connector, originally designed by Apple but later adopted as an industry standard. The mini DisplayPort is a smaller version of the plug without the locking latches. It offers the exact same performance as the full-size version. While it was very popular on laptops for many years, it has largely been replaced by USB-C. DisplayPort Alt Mode over USB-C. In the modern era, many DisplayPort connections don't use a DisplayPort cable at all. DisplayPort Alt Mode allows a USB-C port to switch its internal wires to carry a native DisplayPort signal. This is how most modern one-cable docking stations work. A single USB-C cable can carry your video to your monitors, connect your keyboard and mouse, and charge your laptop all at the same time. Professional features, adaptive sync and high bit depth. DisplayPort is highly regarded by professionals and gamers because of its superior handling of signal timing and color. Adaptive Sync. DisplayPort was the first interface to standardize variable refresh rate technology through its Adaptive Sync feature. This is the underlying technology behind AMD FreeSync. It allows the monitor to wait for the graphics card to finish drawing a frame before displaying it. This eliminates screen tearing, those ugly horizontal lines that appear when the computer and monitor are out of sync, and provides a much smoother experience in fast-moving games and simulations. Superior color depth. While many HDMI connections are limited in how they handle high bit depth color, DisplayPort supports full, uncompressed 10-bit and 12-bit color even at high resolutions. This is vital for photographers and video editors who need to see billions of colors to avoid banding in gradients like a sunset or a clear blue sky. Troubleshooting the no-signal issue. A common issue technicians face with DisplayPort is a black screen or a no-signal message even when everything is plugged in. This is often caused by a low-quality cable. Because DisplayPort operates at such high frequencies, cables must be very well shielded. A specific problem to watch out for is the pin 20 issue. According to the specification, pin 20 carries power to run small adapters, but it should never be connected in a standard male-to-male cable. Some cheap, non-certified cables have pin 20 connected, which can cause power to flow backwards from the monitor into your graphics card. This can prevent the computer from booting up or even cause permanent hardware damage. A technician should always look for the VESA certified logo on cables to avoid these dangerous and frustrating electrical issues. By understanding the packet-based nature of the signal, the power of multi-stream transport for multiple monitors, and the physical security of the locking connectors, a technician can leverage DisplayPort to create the most powerful and reliable visual workstations possible.